Hello, today my name is Father Rasha. I'm here to teach you 4.2 congruent and triangles. Congruent figures are two figures or shapes that are exactly identical. For example, this circle and this circle would be congruent. Now, for example, a circle and a triangle would not be congruent because they're two different shapes. Some shapes that could be congruent could be in different positions. So such as this triangle, a triangle congruent to it could be upside down or to its side. And yet it'd still be congruent because it's the same shape but just in a different rotation. Now, you have to know how to be able to name congruent parts. So because we have two congruent triangles here, this base will be the same as this base, and then this side will be the same as this side, and this side, which would be equal to that one, would be equal to this side. Usually naming them would be one mark would be equal to one mark, and then 2 marks would be equal to a second mark, and it also could go up to 3 and more depending on how many sides you have in your shape. Theorem 4.3. Theorem 4.3 proves that if two angles of one triangle are congruent to two angles of another triangle, then third angles are also congruent. So if this angle here is congruent to this one, and this angle here is congruent to this angle, then that means that this third angle must be congruent to the other triangle as well. And as these dash marks, the angles prove the same thing. One little half circle means that these are equal, 2 would be that these are equal, and 3 shows that these are equal. Now I'm going to explain Theorem 4.4. Theorem 4.4 is the properties of congruent triangles. The properties of algebra in general are the reflexive, symmetric, and transitive. Now, in Theorem 4.4, the reflexive property shows that if triangle, let's say ABC, the reflexive property proves that triangle ABC will always be congruent to itself. Now, the symmetric property, let's say we have triangle DEF, proves that if ABC is equal and congruent to DEF, then DEF is congruent and equal to ABC. And the transitive shows that if we have triangle KLJ, then if ABC is congruent to DEF, and then DEF is congruent to KLJ, then KLJ must be congruent to ABC. Now I will teach you how to use properties of congruent figures. As you can know that these two figures are in different positions but are completely congruent. Now you will want to find the value of M and your Y. So you know that L and M is equivalent to G and H. So then you will start an equation of 8 equals 2x minus 3. Now what you want to make sure that you do not do is that you don't include these m's, because those stands for meters, so they're not a variable. Now to start the equation, what you're going to do is you're going to add the 3 to the 8, basic algebra. So we have 11 equals 2x, divide your 2, and you come up with 5.5, which equals your x. Now for the y, you have measurement of your n and your e. Now to do this, you put the 72, which would then equal your 7y plus 9. Now you minus the 9 and get 63 equals 7y. Divide your 7 to get 9 equals y. That is your x and y to find the properties of congruent figures. Now I will explain how using the third angle theorem, which will help you in finding the angles of two congruent triangles. Now, as you can see, I have triangle NML and RTS. Now, S and L are congruent, and so are M and R. Now it leaves the question of finding M and T. But because you know that S and R and L and N are completely congruent, then that's so using the transitive property, you know that M must be equal to T. So to solve for this problem, first you take 180 and then you subtract from 180 these degrees. So when you subtract those degrees from 180, you're left with 60. So with your 60, which will be your M, you take 60 equals the 2x plus 30. Now you subtract your 30 from your 60. That leaves you with 30 equals 2x. And divide your 2. That way you're left with 15 equals x. So your x will then be 15.